Our first type of molecule is a linear molecule with 3 atoms and 2 bonds. Situated around the central atom, you have a bond on each side. This gives it a hybridization of sp because there are 2 bonding pairs and a bond angle of 180 degrees on both sides. Our next molecular shape is trigonal-planar with 4 atoms and 3 bonds. Situated around the central atom, you have 3 bonds as far away from each other as possible, and these 3 each bond to one of the other 3 atoms, as shown. This gives the central atom a hybridization of sp2 because there's 3 bonding pairs and no lone pairs. Creates an angle of 120 degrees between each of the bonds, all in the same plane.
So 3 atoms, 2 bonds, a lone pair. It's bent with a bond angle less than 120 degrees, and it's hybridization to sp2.
Alright, we have 5 molecules, one of which is a central atom, and then we have our 4 bonds, which forms a tetrahedral molecule. So for you have your central atom, one on top, got to crush. Put that one in last. And then you have your 4 bonds. So when you hold it up, it kind of goes like a shape like that, as much as you can. And so you have bonding that's it's more than 90, but less than 120 of the bent and trigonal planar. Gives you 109 degrees and a sp3 hybridization around your central atom. The next type of molecule is trigonal-pyramidal, where you have your 4 atoms, one of which is your central atom. You have 3 bonds, and you have 1 lone pair. So around your central atom, you have your 3 bonds situated in the 3-dimensional space, like so. And you place your lone pair on the top, giving it a setup similar to the tetrahedral, but with a lone pair instead of that 4th bond. And your central atom forms bonds with the other 3 molecules, giving it an sp3 hybridization because 3 bonds, 1 lone pair, sp3. This gives you a bond angle of slightly less than 109 degrees because there's lots of room around the lone pair. This molecule type, or molecule shape, is bent. You have 3 atoms with the central, 2 bonds, but this time you have 2 lone pairs. So on your central atom, you have 2 bonds connected to these 2 other atoms. Yeah, atoms. Then you have your 2 lone pairs. Or there's 1 lone pair. There's another lone pair. The hybridization on this one is sp3 because you have your 2 bonds and your 2 lone pairs, but the angle on this is less than 109 because again your lone pairs take up more space than your bonds, and 2 lone pairs would obviously take up more space than 1 lone pair, so it squeezes your bonds together even more to make it about 109 degrees. The geometric shape is trigonal bipyramidal, which involves 6 atoms, one of which is your central atom, and 5 different bonds. So arranged around your central atom, you have 3 bonds which form the trigonal planar modes. You have 120 degrees between them, and they attach onto these. And then you have 2 bonds, one on the top which forms 90 degrees with one like this, and then one on the bottom that'll form 90 degrees like this. So what you end with is something that looks like a pyramid on the top and a pyramid on the bottom with sp3d or hybridization around the central atom.
Here we have seesaw, 5 atoms, 4 bonds, hybridization of sp3d. Angles on top are a little less than 90, and on the bottom less than 120, and lone pair on top. Here we have the T-shape with 1 central atom, 3 bond pairs, and 2 lone pairs. So as you can see, it's a little less than 90 degrees. You have the 2 lone pairs on top. And the hybridization is sp3d. Here we have the linear with an sp3d hybridization, 1 central atom, 2 bonds, and 3 lone pairs. Forms an angle of 180 degrees. 2 lone pairs go on top, 1 goes on bottom. There you have it. So here we have the square pyramid. Has a central atom, 5 bond pairs, and 1 lone pair, giving it a hybridization of sp3d2. Bond angles are a little less than 90 degrees. You can see you have 4 bonds around, 1 bond under, and the lone pairs go on top. Here we have the square planar, 1 central atom, 4 bonds, and 2 lone pairs. Bond angles are 90 degrees. And you have the lone pair on top and the lone pair on the bottom, which gives it a hybridization of sp3d2. Here we have the T-shape with the hybridization sp3d2. Has a central atom, 3 bonds, and 3 lone pairs. Bond angles are a little less than 90 degrees. And the lone pair goes on the bottom and on the sides. There you have it. Here we have linear with hybridization sp3d2. There's a central atom and 2 bonds and 4 lone pairs. Lone pair goes on top, on each of the sides and on the bottom, so it cancels out the bond angle so it stays 180 degrees.
So our next molecular geometric shape is octahedral, and for this one we have 7 atoms involved, and one of which is the central atom, around which are situated 6 bonds, each 90 degrees from each other, as far away from possible. This creates sp3d2 hybridization around the central atom, because there are 6 bonding pairs. And there you have it. As you can see, pretty close to 90 degrees for our model. To review, we have linear, bond angle 180 degrees, hybridization SP. We have trigonal planar, bond angle 120 degrees, hybridization SP2. We have bent with an angle of less than 120 degrees due to the lone pair and a hybridization of SP2. Here is tetrahedral, bond angle is 109 degrees with a hybridization of SP3. This one is trigonal pyramidal, bond angle less than 109 degrees, again due to the lone pair, and a hybridization of SP3. Here we have bent again, but this time with 2 lone pairs, which gives it an angle of less than 109 degrees and a hybridization of SP3. Here is trigonal bipyramidal, with a hybridization around the central atom of SP3D and 120 degrees bond angle between the middle atoms and 90 degrees between the middle and the top. This one is seesaw shaped, which is similar to trigonal bipyramidal but with a lone pair, which squeezes your angles down to less than 120 degrees and less than 90 degrees, keeping your central atom hybridization of SP3D. Here we have a molecule that is T-shaped, with less than 90 degree angles squeezed together again by the 2 lone pairs, and central atom hybridization of SP3D. Here we have linear again, same as before with 180 degree bond angle, but this time you have 3 lone pairs, which makes the central atom hybridization SP3D. Here we have square pyramid shaped, with a bond angle of less than 90 degrees because the lone pair on top squeezes your angles just like all the rest, and you have a central atom hybridization of SP3D2. Here we have square planar, which is similar to the square pyramidal but with one of the bonding pairs replaced by a lone pair. You have bond angle 90 degrees and the central atom has hybridization of SP3D2. Here's a molecule that is T-shaped with bond angle less than 90 degrees, again squeezed by the lone pairs, and a central atom hybridization of SP3D2. Here we have our third type of linear molecule, this time with 4 lone pairs, which all cancel each other out, and leaves us with a bond angle of 180 degrees and a central atom hybridization of SP3D2. And finally, we have our octahedral molecule, which is a central atom with 6 bonds around it, giving it 90 degrees bond angle and a hybridization of SP3D2.